Crash Course Instrumentation, Saturday Special, the shocking history of voltage, current and resistance. Welcome to our very first Crash Course Instrumentation, Saturday Special, where we uncover the fascinating, weird and often electrifying history behind the concepts we work with every day. Today, we're going back in time to explore how humanity came to understand voltage, current and resistance. Concepts that now power everything from Teslas to tea kettles. So grab your coffee and let's rewind the voltage meter to the 1700s. It all starts with a frog's leg, seriously. In 1780, Italian scientist Luigi Galvani was dissecting frogs, as one does, when he noticed something bizarre. When he touched a frog's leg with a metal scalpel during a lightning storm, the leg twitched. Galvani believed he had discovered animal electricity, some vital energy inside living beings. This curious twitch would later lead to the term galvanism and inspire Mary Shelley's Frankenstein. But more importantly, it sparked an epic scientific feud. Enter Alessandro Volta, another Italian scientist who thought Galvani had it all wrong. Volta believed the energy didn't come from the frog, it came from the metal. To prove it, he stacked alternating layers of zinc and copper with brine-soaked cloth in between, creating the world's first Wayne battery in 1800, the voltaic pile. It didn't just make frogs twitch, it lit the fuse on the electrical age. From sparks to systems, Volta's invention made electricity more than just a static curiosity. For the first time, it could flow, be stored, and, crucially, be measured. But what exactly was flowing? In the early 1800s, a French physicist named André-Marie Ampère got involved. He was the first to define our electric current as a flow of charge and began developing mathematical laws around it. His name now lives on in the unit de ampere, or amp, for measuring current. Around the same time, Georg Simon Ohm, a quiet schoolteacher in Germany, conducted dozens of meticulous experiments trying to understand how electrical current and voltage interacted with different materials. In 1827, he published a formula that would become legendary. Whisky, Eichstorschur, ah. That's right, Ohm's law. It tells us how voltage, current, and resistance relate in any circuit. And it's been the backbone of electrical theory ever since. Fun fact, at the time, Ohm's peers mocked his work. The Prussian government even dismissed it as a tissue of naked fantasies. It wasn't until after his death that Ohm was recognized as one of the foundational minds in physics. 10. Instruments of discovery. With these new ideas, inventors started building tools to measure electricity. One of the first was the galvanometer, an early type of ammeter that measured small electric currents by deflecting a needle with magnetic force. These devices were delicate and beautiful. Brass frames, polished wood cases, glass dials, the kind of gear you'd expect in a Victorian mad scientist's lab. And they paved the way for the rugged multimeters we use today. The evolution of these tools shows just how deeply instrumentation and electrical theory are linked. Without accurate instruments, scientists couldn't refine their theories. And without good theory, the instruments wouldn't have had anything to measure. Oh, so what did we learn? Galvani discovered twitching frogs and started a debate. Volta turned that debate into the first working battery. Ampère defined current. Ohm's described resistance and gave us a law still used in every instrumentation classroom. And all of this happened before anyone really understood what an electron even was. What they built was based on brilliant observation, wild experimentation, and, occasionally, some healthy rivalry. Size, what it means for us today. The concepts of voltage, current, and resistance aren't just math. They're the product of a centuries-long journey of curiosity, creativity, and experimentation. Understanding where these ideas came from makes us better at using them today. So the next time you're calculating voltage drop or checking continuity on a loop, remember, you're standing on the shoulders of frog zappers and resistor rebels. Thanks for watching our first Saturday special. If you enjoyed this deep dive into history, give it a like, subscribe, and leave a comment about your favorite weird moment in the history of science. And if you're curious to learn more, the original source for this video came from Section 5 of Tony R. Kuphaldt's Open Source Model series. Check it out here. HTTPS ibiblio.org/Kuphaldt Socratic Model Volta mais via PDF. See you next Saturday for more electric tales and instrumentation adventures.